wanted to take the chance to show off some of my collection. These are places that I won't be going anytime soon, so I feel like I might as well show them off. Now this is labeled Opal from Nevada. These are all common opals that I found. We struck onto a creek up there. We were up hunting fire opals, which I'll show you sometime. Black true fire opals from the Negro opal mines up there. And anyhow, we stopped along a roadside. My parents had already been there once, and we stopped along a roadside and climbed up to the top of a little butte, and guess what was weathering out of the dirt everywhere? So I wanted to show you my collection. I keep them in water so that they're pretty, and then this is a plastic container. I was keeping stuff in glass. Rocks and glasses kept ending up being a bummer no matter what. So these are just these about a $2 spice container, and it's a good way to hold stuff. But the water, because I don't want to put anything else in there, can get weird. You know, kind of, it's gone brown. You leave it for too long, it'll get green. So I'm going to go ahead and clean it out, dump these out, and we can take a look at them. I got them dumped out. Let them drip for a little while. Oh man, I love going through this pile. You know, it takes me so long. I've probably thrown some other good ones from my other hikes in here, but a lot of these were found in 1 week-long excursion, and oh, it's just a blast. Let me show you these. So this was kind of a heyday, you know. It was way out in the deserts where there's nothing left, and everybody's up there looking for super precious opals. The locals are used to the precious ones. They used to find them on the surface out there all the time, and so these are just, you know, second even to those. So, but for us, we were like, oh my god, you know, because it takes so long usually with the banding and that. I have to get my flashlight out here. But yeah, awesome. Okay, so this is how we do this. Jams. Yeah. Okay. Let's carefully spread out my collection here. God, these are some of my favorites. Okay, so here's an example. This is a little branch. Do you see that? So it's a fossil made out of opal. You set that on the black. It's better than my fingers. Look at that. And that is almost pure. You can see it's just totally see-through. These have mostly the blue and the yellow, and they're lined up, so they're what do you call it? So their little parts, their atoms inside haven't fractured to give you that refraction of the precious opals, but they are still a silicate. You can see there's so many bubbly forms of it. I'm inside, and we don't have the greatest light, but I'll get a couple different flashlights. Oh yeah, this is something else that's been torturing us. Some of these, if you ever hunt, and remember, a lot of gems occur together. If you've ever hunted sapphires in the sapphire creeks, well, these were showing up with these, and you never know, because that's oftentimes what little sapphires look like. But no, another one of those things that we haven't got tested, and the soil out there had a strong green. All of these had a little bit of greening to them, so it's not necessarily the blue of a sapphire, but it's the shape of some of these. It was kind of bugging us because they kind of remind us of sapphires. But yeah, look at the fire. So this one has more of that orange glow to it. It's got more of the yellows. Okay, I'll be right back. Told you I was a hoarder. This may look like quite a bit, but let me tell you, when we're out there, Nevada is basically, and eastern Oregon, eastern Washington, all their vegetation is gone. And when you see me walking through a creek and I am picking up 10 of these in a day out here in California, where you have vegetation on what, 80% of the soil, that means that if you burnt everything up, if you made it into a desert right then and you let the water and wind blow away all of the organic soil to where what you had was minerals, well, that's what eastern Washington, eastern Oregon, Nevada, a lot of the deserts in the world look like. And when you go out there, I mean, the minerals are just laying wide open for you. So you can go out to the creeks and all the public spaces out there, and then when you go into the bars and into the restaurants, you talk to the locals, they'll instantly tell you where spreads are. And the miners are, it's so far out. Let me tell you, we traveled for a day and a half to get from the middle of California out to Winnemucca, and then another day out to Denio or Denio, however you pronounce it, and then another day of driving to get out to the mines and areas. But this was just a creek on the side of the road. But that's what I mean. Everywhere we stopped, everywhere we looked, there was just minerals and plethora everywhere. So any place that's like that, any place where there's been a fire, any place where there's heavy erosion, roads, creeks, anywhere where the forces have eaten their way down through all the organics and all the plants. So that's just a tip. Every time we go out to the desert, it's just a rock hunting bonanza. You come back with jars full of 10 different stones you weren't even looking for. So you want serendipity, go to where the plants aren't any longer. It was really nice getting to find these, so many in a short period of time. It gave us a chance to look at the shapes and kind of understand how everything was being made. And that whole region is famous. It's one of the 2 spots in the world where black opals come from, and one of the main regions in the United States where precious opals come from, meaning, you know, having the fire to them, the refraction and stuff. But you can see, here's an example. These are all branches. These are all basically fossils made out of the opal material. Let me get you some close-ups here. Now, I collect other fossils. There's a video of mine on Quest for Treasure where you can see these exact branches but made out of the sandstone that they're in. But it's just an example of a material, of a mineral filling in a void. So that's kind of the key to what you're looking at here, is that this is a really flowy mineral, right? So this is, you know, mostly silicate. It's glass. These opals, this type of opal, I forget what percentage, you know, they vary. The less stable they are, the more water they have in them. But glass, here's the story that you always hear, is in the old cathedrals where they put in stained glass. It's super thin at the top now and thick at the bottom, because glass is actually a fluid. It's a very slow moving fluid, and over hundreds of years it's pooling at the bottom and getting thin at the top. So these are in the same essence, more water, more fluid than they are actual solid, even though they're sitting there in solid form in front of you, if you can understand that. And that's because of its silicate, of its water content, I guess. That's how I can understand it. And just as a hobby collector and not a master geologist or anything, this helped me understand that, because I started to perplex over the shapes, and there are so many perfectly round ones, and I realized that this is like quartz. So this is something that fills voids, whether it's branches, you know, so there was a branch rotten there, or let's say maybe a bubble in the mud, or some other stone, or these could be seeds, you know. I can never decide. These are common shapes that you start to see, and these, when I find them in the you know, these look a lot like petrified seeds that I find in flotsam and jetsam and fossil beds and stuff. Or they could be bubbles or round voids that were left squished. There's a lot of forces in nature that make things round, from planets to bubbles, you know, when they're acted upon all sides. And let me tell you the region where this is coming from. It's heavy in fossilized wood, fossilized opal wood, obviously. Half of the black and precious opals that you find are actually cast into, they're actually like a fossil of some organic matter, usually wood, and you know, you can find it all by itself, but over and over and over while we were there, people were finding them and they were branches. So I think opal likes to fill voids, and the area where we were in had been bubbling mud pots, you know, look like the sulfur mud pots of Lassen, or let's see, you know, Yellowstone, Old Faithful, any of the bloop bloop bloop, and you can see the trees die and fall into it, and their branches fill with whatever minerals are there, and some become fossilized and some become mineralized to the point of when they're you know, they're little branches. You can see the little stublets of other branches coming off. This is probably the best example of that. And if you know fossils and you collect fossils, you're like, yep, that's a little branch. I don't know if in this light it'll pick up the detail of the inside. There you go. But they're pretty milky on the outside and white on the inside. I mean, clear on the inside. So these are pretty pure. Here's an example of what I'm trying to say. It's more milky on the outside, and then the inside is pretty pure. Some of them have a little core. That's all due to whatever mineral has flowed in. This was cool. This was a little horse tooth that came out of the thing that we picked up. And I was like, okay. That I picked up. This is, everybody ended up with a collection that was pretty big. This one's mine. Some of these trap things in them, so I don't think that's an inclusion. I think that those are stones trapped in it. You see it literally, it flows around things and encapsulates them. Is that how you say the word? Here's an example of some of that probably, but more on the surface. And where I am down in mid-California, a lot of the common opal that we find has stripes on it, so whatever it erodes out of leaves more of a striped pattern. You can see that this softer material is being eroded away by the elements, and it's leaving the little pits that gives it that little crater look. Here's more of another example of it. I don't know what that type of stone is. You can see some are in or some are out, but as those erode out, it'll leave the characteristic pits that are on all of these. Here's some where the stone is almost all the way gone. So I believe that this clear silicate flowed in around whatever that was, those little grains of something. Who knows? And now that's eroding away. Here's the outside of one. I don't know if you can pick that up, but they're pitted. Where's a good one? Here's a good one. Ends up looking like the moon. So here's the question. Are those craters on the moon from impacts, or are they from softer material being eroded away? The world may never know. Yeah, but these are pretty pure. And all of these were on a bluff. Wouldn't you love to see the fast forward of the last like 5 million years there, where like the trees go away and then all the soil and then the wind and it just blows it off. These were literally amongst the pebbles, if you can picture that. Every 100th pebble was a little opal laying there. And these are the ones that are perplexing us because of their color and their look. It's a lot like sapphires, and we're getting closer to sapphire country. Here's a couple you can see that actually have little bubbles still trapped in them. So it's what the round ones could be. There's a lot of round ones. They could be mud pot bubbles, bloop, you know, but it doesn't make it to the surface because it's mud. And then the opal fills that space in. But yeah, maybe too much babbling. But that's the cool part about being able to hunt and hunt around and see things in different areas, is you kind of can get self-taught from just figuring stuff out, thinking it out and seeing stuff. I mean, half of these look like fossils that I find in other places. See, this one's got red to it. Whatever that mineral is that's occurring with it, that was round in little miniature nodules that erodes away. That's a, oh, how can I say? It's another creature that's living with it that are making this particular batch very characteristic. So I would say they're kind of entwined. You see the crystal pocket inside that one. Look at the little specks inside of that. If you have really good internet right now, you can see that, the little dots. Dots. See the little layers in there. All the different stones. Here's another. Crystals on the inside and opal on the outside. Another one like that. All these rounder ones might have crystal pockets on the inside. Should make for excellent cuts and slices, that's for sure. The bigger ones, really pure stuff up there, and you can see the flow to it. You can see it, the shape. If that's picking up, you see that? It looks like wax. You know, half of these look like wax poured into somewhere. So you get that. It's like frozen in time because we're only here for 100 years and I'm only looking at these for a few minutes. But these were like fluid. This is motion trapped. I don't know how else to explain that about these opals. All of the opals, the precious opals, were the same way, and all the layers of rock that this was occurring in was sedimentary, and you could tell that it was just mud after mud after mud with little islands of life and trees, and, you know, picture Yellowstone, and then everything that fell in there having the possibility of having all of those rich minerals that are in that type of setting flow into it. And you can see, oh, the yellow shows up. That's what we were told about these, is they're high in the yellow and high in the blue. But they're, the grain in it, in the atoms or the molecules, I guess, is still lined up to where they don't give you that broken. All you would need is that broken grain in it, and they would be the precious opals. So they're pretty close. But the factors didn't line up, so you can see the blue to it when it's against a background of black, and then when you put it against other things, the yellow shows up, and some of them can highlight in the greens and oranges and reds and stuff, depending on what minerals seeped into them. Imagine this green could be what? Is it magnesium or manganese? The green that comes when iron gets really old and it goes green. Because, but then when that soaks into these minerals, does that make a sapphire? I don't know. Those are the questions. Okay, so here, see the little lines down inside there? Those are what I'm familiar with. If anybody knows the exact reason those occur on the outside of common opals. Now we'll do a bunch of individual shots, and then that'll be the wrap up. And just wanted to show you guys my insane collection of common opals, and maybe we'll pick out 3 of them here, and if it keeps raining and raining and raining endlessly, we'll make some jewelry out of them, and I'll show you how to drill stones.